Hello AP Chemistry students. It is Sunday afternoon and I'm hoping that y'all are starting to think seriously about studying for your test in the morning or in the afternoon, depending on when you're going to take it. I just wanted to kind of give you some study tips, hints, review guides. I'm holding in my hand the actual test, and so I just kind of want to go through this and just talk about concepts that you need to know. So the first thing that we talked about was solutes, the different types, and you need to know that, be able to recognize if something is an electrolyte or a non-electrolyte. Okay, so go back in your notes, and electrolytes being ionic compounds, acids, know your 6 strong acids, bases, know where to find those on the periodic table. Okay, so you definitely need to be able to know how to do that. Okay. We also talked about the solution process of the solute, solvent, solvent, all those different attractions. Know the names of each type of attraction. And in doing that, you need to be, we know that like dissolves like. So the more similar two things are to one another, then the more soluble they're going to be. So what type of substance is going to be most soluble in a non-polar solvent? Well, the most non-polar. What's going to be most soluble in water, a very polar, is something that's polar, or more specifically, something that can form hydrogen bonds with the water. Okay, so you need to be able to, explain the why and the how that happens based on the different types of attractive forces. Remembering that when an ionic compound dissolves, it's the ion to dipole attraction. When you put nonpolar in with polar, that's going to be a dipole, induced dipole, which is generally very weak, not strong enough to overcome the much stronger hydrogen bonds in the water or the polar solvent, and so consequently they're not going to be soluble. So we need to be able to differentiate and tell which things will be soluble and which ones won't, based upon the polarity. Okay, you do have to be able to do some molarity type problems where you calculate molarity, very similar to the lab and being able to calculate grams. Okay, we also talked some on the factors that affect solubility, how temperature affects some. If it has a positive heat of solution, if it's endothermic, according to Le Chatelier's principle, positive heat of solution means that as you increase the temperature, the solubility will increase. That's the case for most solids and liquids. However, if something has a negative heat of solution, it's exothermic, that means that as you increase the temperature, the solubility decreases. That is true for all gases and some solids that happen to have a negative heat of solution. So, and then we talked about pressure. Pressure has no effect on solids and liquids, but pressure for gases follows Henry's law, and so more pressure means more solubility. So you need to know how solids and liquids and gases solubility will change based upon temperature and pressure. So that's something that you want to definitely look at. Okay. In addition, I mentioned this in class, but it may not have been on the video, so I want to say it again, that when you're looking at things dissolving in water, an ionic compound dissolving in water, that ion to dipole attraction is still a Coulombic attraction. So it's measured by Coulomb's law. So you definitely need to understand Coulomb's law with lattice energy and be able to predict the differences there. Okay, but the same rule applies to the ion to dipole attraction between the water and any ion that's dissolving. So in other words, water is going to have a much greater energy of hydration on a +2 ion than it is on a +1. Okay, so that's just another thing to make sure that you understand, and make sure that you refresh and review Coulomb's law and lattice energy and how we can differentiate the melting and boiling points of ionic compounds with that. Also remember, Lattice energy only applies to ionic compounds. Okay, it does not apply to covalent. Covalent compounds, we use IMFs, London forces, dipole, and hydrogen bonds. Okay, so recognize whether it's ionic or covalent. Okay, there is a dilution problem on here, and I'm just going to tell you to make sure you read it carefully. There's a little bit of a trick on that one, so make sure you just read the question carefully on the dilution problem. Okay. We talked briefly about a saturated solution. A saturated solution is one that is completely full. Generally, there's some solids sitting at the bottom. But remember, it's not static, it's dynamic. In other words, some is dissolving, some is crystallizing back out. It's in equilibrium, meaning that the forward rate and the reverse rate are equal. So as much sugar is dissolving, the same amount then precipitates or crystallizes out. Okay, so it's a reversible reaction. It's in equilibrium, but that means forward rate, the dissolving, is equal to the reverse rate, the precipitation. Okay. All right. If you know all of these things, then you should be fine. Practice some of the multiple choice that I gave you, the AP multiple choice questions. Those will be on there. Now, you will have to be able to tell me, about hydrogen bonds, where hydrogen bonds will form. We did some practice problems where you saw the dotted lines with the hydrogen bonds. Okay, so you're going to need to be able to do that, and you're going to be able to, in short answer, have to be able to tell me why one thing is soluble and another thing not soluble in water. Okay. Finally, I just want to let you know that bonus question that I talked about last chapter, where we convert from molarity to molality to mass percent to mole fraction, that bonus is on this test. Okay, I didn't put it on the last test, so I'm including it on this test. Okay, so know what your electrolytes are. Also just remember when we talk about the terms, know your terms: miscible and immiscible, an emulsifying agent, an emulsion. Okay, remember soap was an emulsifying agent. It had a long hydrophobic nonpolar end and a small hydrophilic polar end, which kind of linked the two nonpolar and polar solute and solvents together. And that's how soap works. Okay, so you need to be familiar with that as well. But that's pretty much all of the concepts I just went kind of through with this. Just remember that in a solution, if it's exothermic, if the overall delta H, remember delta H of solution is delta H1, which is your lattice energy, delta H2, which is your solvent, which we generally don't worry about, and delta H3, which is your energy of hydration. If it's an exothermic reaction, that means the energy of hydration is greater than the sum of 1 and 2. If it's an endothermic reaction, that means 1 and 2 is greater than 3. Okay, so just understand that whole solution process. We spent a lot of time on that, talking about the energy changes. So I asked several questions about that on this test. Okay, so this is just a quick overview of what you should be studying. Okay, the practice problems on AP, the Princeton review problems that were assigned, and your notes. Go through the notes that I gave to you, both the typed ones that I posted as well as all the ones that you took. And here's kind of a crazy thing. You might even want to read the textbook in chapter 13, okay? Because there's a lot of good information in there. All right, I will not be there tomorrow, but I think everything's going to be straightforward. This is going to be an open book, open note test, not open friend. And so everybody needs to bring their Chromebook to class tomorrow, because the test is going to be on the Chromebook, and then you're just going to have to answer multiple choice and free response on a separate sheet of paper. All right, hope you have a great rest of the weekend. I'll see y'all on Tuesday or Thursday, depending upon which day you come to school. All right,